we can say that our random variable, the number of out-of-state vehicles we're counting successes, follows a binomial distribution, where n is 9 and p is 0.25. 25% of cars are from out of state. So if we want to know what's the probability that exactly 2 of the next 9 are from out of state, well, now we can use the binomial PDF. So we want to know what's the probability that x is 2. So we use binomial PDF, where n is 9, p is 0.25, and we want 2 successes. And you should get 0.3003, rounding to 4 spots. Okay, so this means there's a 30% chance, and some change, that exactly 2 of the next 9 are from out of state. Okay, we're just answering the question. What's the probability that exactly 2 are from out of state, out of the next 9? Well, there's a 0.3003 chance, 30.03% chance that will happen. What's the probability that at most 2 of the next 9 are from out of state? So if we want at most 2, that means we want 2 or fewer. So we could have 0, 1, or 2 from out of state. Okay. So what we're looking for is what's the probability that x is less than or equal to 2. And as we saw in the last example, this means that we could have 0, or, so plus 1, or 2. And we've already found 2, so that was 0.3003. So now we find 1 and 2. So for the probability that x is 0, we'll use binomial PDF. N is still 9, p is still 0.25, but we want 0 successes. And for x is 1, we'll do the same thing, binomial PDF. 9.25, but now we want 1 success. So we'll find those kind of at the same time. So for 0, there's what you would enter. You should get 0.0751. And for having 1 out-of-state car, that's what you would enter, and you should get 0.2253. So we add those together. So we have 0.0751 plus 0.2253 plus 0.3003. And you get about 0.6007, depending on how you rounded. So that means there's about a 60% chance that at most 2 of the next 9 cars that pass through the checkpoint are from out of state. In this problem, we only have a 25% chance for success, so we would expect to not have too many out-of-state cars. So it should be a decently high probability that we would have at most 2. None, 1, or 2. How many would we expect to see from out of state? Well, that's the next question. To find the mean, you just take n times p. So 9 times 0.25. You can think of that as 9/4, or what is that, 2.25? If I did my mental math right. Yeah. 2.25. So on average, in the next 9 cars, you would expect a little over 2 to be from out of state. And how spread out is this distribution? So for the next 9 cars, what's the standard deviation? So again, a little bit of math. We're going to take the square root of n times p times 1 minus p. So the square root of 9 times 0.25. 1 minus 0.25 is 0.75. So you multiply those all together, and you should get 1.6875. But we want the square root of that. So what you should get is 1.299. And if you wanted to interpret this, you'd say something like, on average, the number of out-of-state cars that pass through the checkpoint is within 1.3 of 2.25. So on average, the number of out-of-state cars we will see would fall between about 1 and, what's that, 3.5? Yeah. Roughly between 1 and 4 cars will be from out of state. I'm doing a little bit of generous rounding. On average. Could have less, could have more, but that's where a big chunk of the distribution will fall. Within 1.3 cars of 2.25. Okay, so that's the binomial distribution. For Thursday, we'll start on page 12 with what we'll get into is the bell curve. So what I would recommend you doing is go back through the examples from chapter 5 as well as the ones at the beginning of the chapter 6 notes. And you'll see that in many of them you can probably resolve them treating your random variable as a binomial random variable. So for example, look at the consonants and vowels problem and try to recreate that probability distribution in this binomial way. You can do that for many of the previous examples we've done, so I recommend that you do that to get some more practice. So we'll stop here. Thursday's video will pick up on page 10, or sorry, page 12. And we'll start talking about another named distribution, the bell curve or the normal distribution. And when we get here, we'll see that we move into quantitative continuous variables. Everything up to this point has been quantitative discrete. So now we'll move back to continuous world. So that's it for now. Let me know if you have questions. Talk to you Thursday-ish. Well, and the Tuesday evening meeting.